Okay, so this is where we stop assuming angle C is 90 degrees, because we're talking about non-right triangles here. Our law of sines is a set of proportions. So when these are not, none of these are right angles, the law of sines says that if you were to put the sine of A over side A, so compare those, make that ratio, that it is equivalent to sine of angle B over its opposite side B, which is also equal to sine of angle C over its opposite side C. Okay? This is our law of sines. And so what we're going to do is still solve the triangle. So we're still finding all of the other pieces, but we don't know that we have a right triangle. And so we'll have to use our law of sines to help us figure out the angles and sides. Okay? So if we're given this information here on our first one, angle A is 35, angle B is 62, and side A is 15. We need to find angle C, side B, and side C. Anyone think they know how to find at least one of those real quick? Angle C. We already know two angles, so how do we find the third? Add them up and subtract from 180. So if we do 180 minus 35 minus 62, we get that angle C is 83 degrees. Now for side B, since I know angle A and side A, I can set up sine of angle A over side A equals, I would take angle B, which is 62, over side B, which we don't know. From here, cross multiply. So we'll have 15 sine 62 equals B times sine of 35. To get B by itself, we're going to divide both sides by sine of 35. And then this is what we plug into our calculator. And when you go to plug this into your calculator, you want to be very careful about putting the numerator in parentheses divided by your denominator in parentheses. Because if those are off, then it's not going to divide correctly. So I would type in parentheses, 15 sine 62, and you're going to have to end with a double parentheses, one to close your sine, one to close your numerator. Then hit divided by sine 35. You should be coming out with 23.091. Anybody not getting that answer? Okay, so then we found B, 23.091. So for C, what proportion are we gonna set up? So I would stick with using sine of 35 over 15. So stick with A since that was our given. But now I'm going to use my angle C that we found, 83, sine of angle C divided by side C, cross multiply and go through the same process. So C times sine of 35 equals 15 sine 83. Divide both sides by sine of 35 to get C by itself. And again, watch your parentheses, make sure they're done correctly. You should be ending up with 25.957. So try typing it in, and if you're not getting 25.957, let me know so we can check and see how you're entering it.
Are you rounding the last?
Round to 3 decimal places, yes. Okay, so it's again the same idea as what we did on Monday or Tuesday. It's just using law of sines to do it as opposed to our right triangle trig. Okay. Any questions so far? Okay, so we're going to do one more here where we know angle A, and side B. So we need to find angle B, angle C, and side C. So with this one, since I have angle A and side A, I can set up that proportion, sine 38 over 17. And if I start with finding angle B, because I know side B is going to go here in the denominator, and I'll have sine B on top. So we're going to have to do an inverse here to find our angle. We'll still cross multiply. So 13 sine 38 equals 17 sine B. We'll need to divide both sides by 17 to get sine by itself, the sine B by itself. And then we have to inverse. To move the sine over, we're going to inverse our sine of everything in parentheses there. So some people like to get the decimal before they inverse, which is totally fine. Some people like to just plug it all in at once. I don't care which way you do it as long as it's done correctly. So if you wanted to start by finding 13 times sine of 38 divided by 17, this inside part becomes 0.4708. Then you can inverse sine it, and you should get 28.086 degrees. So check it with your calculator, make sure you're getting the same decimal. If you're not, let me know, and I can help you figure out the calculator error. So if you haven't guessed, this is going to be one unit where showing your steps is going to be crucial, because if I see on your paper that you have this here, then I know the mistake happened in punching into the calculator, not that you didn't know how to do it. So making sure you have all your steps so that I can really see that you knew how to set it up. I don't want you to, you're not going to lose a lot for making a calculator mistake, whereas if I don't know what you typed in, I can't give you anything. Okay, any questions about law of sines? Because that's really all there is to law of sines. For now. There's actually more, but we're not going to learn it till next week. Okay, the last thing with 7.3 is going back to area of a triangle. Do you guys remember? Oh, wait, we didn't finish this one. What am I doing? Sorry.
You didn't continue, but I was like, okay.
No, sorry.
Yeah, I thought we were just going to do it right when we started.
No, we'll do it. Okay, sorry. My bad. My brain is not working well. Okay, so, and other things. So 180 minus 38 minus 28.068. You get 113.932. So I added up angle A and B and subtracted it from 180 to find angle C. From there, we can now do our law of sines. So still sine of 38 divided by 17. Sine of C divided by side C. I know. That's why we try to use the nice ones that are given to us as much as possible, but sometimes you have to use what you find. 17 sine 113.932 equals sine 38 times C, divide both sides by sine 38. And then we'll plug that into our calculator. And you should get 25 point, I got 239. Okay, also just so you guys know, there is potential for your last decimals to be 1 or 2 off, depending on if you rounded early in the problem or not. So the earlier you round, the more off your answer becomes. So we want to try to save rounding as long as possible. Reem? No, because we don't have right triangles here. So if we knew we had a right triangle, so let's say we found B and C and one of them was 90, then yeah, we could. But right now, none of our angles are 90 degrees. Now we're done with that one. Okay, the last thing that I did want to go over is a way to find the area of a triangle when it's not a right triangle. So does anyone remember the formula for the area of a triangle?
1/2 base times height.
1/2 base times height, but the height has to be perpendicular. So we tend to have to use trig to find the height, and then we use that height, plug it in. There's actually a couple of different ways you can do it that are a lot faster.
Really?
Yep.
By like a line.
What?
Like a cheat sheet?
No. Just where you don't have to even find the height to begin with. You can take any triangle with what you know and not have to go through the finding the height of it. You can just find the area.
I wish they could resist.
Again, we give it to you as you're ready for it.
Like a long race.
Okay, so the formula for an area of a triangle can be expanded from 1/2 base times height. It still has similar aspects. It's 1/2, and it's all going to be dependent on the angle that you know. So like, let's say we know angle A. So if we know this one, then I'll take 1/2 times the two sides that aren't the opposite of my angle, so B times C. So my angles here that I know, I'll take 1/2 of these two sides times the sine of the angle I know. And that'll give you the area just like 1/2 base times height would, but without having to find the height. If you know angle B, then it becomes A times C, sine angle B. If you know angle C, then it becomes 1/2 A times B sine of angle C. So which one you use will depend on the angle that you know. So the one example I have for finding our area of a triangle is right here at the bottom. So we have our angle here. We're going to use these two sides to help us find the area. So 1/2 times 16 times 20 sine of 84.5. Type that into your calculator, you'll get the area of that triangle. When you type it in, you should end up getting 159.263. And don't forget to make sure you do centimeters squared. So that's all there is to 7.3.